Hello, the whiteboard is out, so today we're going to do a side of maths. In my previous video, what is nanotechnology and what is nano, we said that 1 nanometer is 1 times 10 to the minus 9 meters. And I had a question, what or where does the times 10 to the minus 9 come from? So in this video, I'm going to explain where that comes from. And I'm going to look at it in 3 different ways. The first is going to be how we define the words nano, micro, so in terms of science. We're then going to look at the mathematics of why this works, and then finally just give you a cheat way of how to work through it quickly and how to get used to using this notation. I should also say here that in a future video I will show you how to do maths with this sort of notation and give a bit more explanation of where it all comes from. So in the previous video, which there'll be a link above me here if you want to click on it to watch, we have said that milli, so in the terms of millimeters, means times 10 to the minus 3. Micro, which is given the Greek letter mu, is times 10 to the minus 6. And nano, which obviously you can get very familiar with these videos, is equal times 10 to the minus 9. And in which case we're always making up for very small numbers to make them in the form of 1 times something. We could also have a notation for bigger numbers, so we'll quite often get familiar with the term kilometers, which means 1,000 meters. So kilo is given the symbol K and is equal to times 10 to the 3. Mega, which would be a million of something, so a megameter would be a million meters, is times 10 to the 6. And we got gigameters, or giga, which is times 10 to the 9. All these numbers keep going up, as you see, in threes or down in threes. So below these on the nano side, you'd have a picometer and a femtometer, which would be times 10 to the minus 12 and times 10 to the 15. And on the other side, these numbers will also go up in threes as well. However, once you get bigger than gigameters, you probably should consider using a different unit, such as light seconds or parsecs. And I know these sound like units of time, because they have the word seconds in them, but they are actually units of length.
Fast chip. You've never heard of the Millennium Falcon?
Should I have?
It's the ship that made the Kessel run in less than 12 parsecs.
So now we're just going to have a brief look at how we can convert numbers to being of this form. So let's say I have a number which is 1,234. We can say that this is equal to 1.234 times 1,000. Because if you multiply this by 1,000, you get back to your original value. For clarity, we can also put a couple of extra decimal points in, just because when we start multiplying by these numbers, you'll have to move your decimal points so you can see where the decimal point comes in and where it moves to, and this is going to be important for later in the video. The question is, how can we write this in the terms of times 10 to a number? And this number at the top in maths is called an exponent. So we're going to go for a brief aside to look at things that we are fairly familiar with in common language, the ideas of to the power 2 or squares. So if I said 2 squared, this means the number 2 times itself, the number of times of the exponent. So in this case it would be 2 times 2, which is equal to 4. In a similar way, if we do 3 to the power 4, we do 3 times itself, the number of times of the exponent. So we can do 3 times 3, which is 2, times 3, which is 3, and then times 3, which is 4, so there's 4 times itself there, which, if we do the mental arithmetic, is 81. We can also do this with the number 10. So 10 squared is equal to 100, and 10 cubed, or 10 to the 3, is equal to 1,000, which we have there. So we can just substitute this in here. So let's take this out, and now we have 1.23 times 10 to the 3. So we've now been able to get into this form of writing your number. The question is, what happens with the minus exponent, which we obviously come across in nanotechnology quite a lot. So let's say we had a value of 2.4 nanometers. We know we can write that as 2.4 times 10 to the minus 9. But to get to this value, when we break this down, we're actually having to divide a number. And this is something I'm going to go into in another video. But if we take a value, and I'm going to write this in terms of algebraically, so x. So if we have x to a power n, so x can be any number, n can be any number, and we put the minus in front of it, so it's x to the minus n, we can write that as 1 over x to the n. So what we're actually saying here is, well, 2.4 nanometers is 2.4 divided by 10 to the 9. So nanometers is equal to 2.4 divided by 10 to the 9, because this part here is actually equal to, so 10 to the 9 is actually equal to 1 over 10 to the 9, and when you have a multiplication of 1 divided by something, it can be written in this form. So this is how this form of maths can develop and come around. So finally for this video, we're just going to look now at what I would consider a fairly easy way of understanding what this means. If we take a number, I'm just going to take the example of 1,234, I'm going to put the decimal points in, and I want to write this in terms of 1 point something times 10 to the 1,000 or times 10 to the 3 like we did earlier. And we want to work out exactly what power we need to do this to. What we can do is simply count the movements of the decimal point. So this is why I put the extra decimal places in. So if we do one movement here, call that 1. We do a second movement, call that 2. And a third movement, call this 3. We can now write this, the decimal point has moved to here, so it's in between the 1 and the 2. We know we're going to be times in by 10 to a number, and we count how many movements we've done, 3. So from the previous part of the video, you can see that this is equal. So we're moving the decimal point to the left, and this gives the positive number. Similarly, if we have a very small number, let's say 0.0000001, and then let's put the 2, 3, 4 at the end. If we want to write this in terms of a times 10 to an exponent, we can again count the decimal points. So we can go 1, 2, 3, 4, 5, and one more, 6. So again, we can do exactly the same what we've done there. We've now moved the decimal point, so we've got the 1.234. Should probably put an equals in. We put the 10. We've counted 6 places, but this time, because we've gone to the right and this number is less than 1, we put the the minus sign in, and we've got times 10 to the minus 6. So this is a really simple way of being able to do it quickly without having to worry about how many tens and how many millions you have to multiply out by. So this is my preferred method of being able to do this. Anyway, I hope you found this useful. If you did, please hit the subscribe button to keep up to date with any more content that I put on this channel about nanotechnology and about maths. And I'll see you again soon.